Answers for the A to A star grade paper. This is the non-calculator one. Question number 1. It is a histogram question. This is probably like an A grade histogram question. It says the histogram gives information about the heights of 540 Christmas trees. Work out an estimate for the number of Christmas trees with a height greater than 3 meters. What I did was this. Here is I first of all worked out how many squares there were here altogether. So in that block there's 200, 175, and so on. So I worked out those 750 altogether. And then I worked out how many were bigger than 3 meters. And that came to 300. So what I did then was put that as a fraction. So 300 over 750 cancels down to 2/5. So 2/5 of the trees are bigger than 3 meters. So it's 2/5 of 540, because they're told there's 540 trees, is 216. So it's roughly 216. That's how I worked it out by using the boxes. Question number 2. P is inversely proportional to V. I'm a bit upset there weren't more questions on here about inverse proportion, but we'll make do with this. So if it's inversely proportional, P equals K over V. So step 1, we're going to calculate what K is. So we can do that using these numbers here. So 5 equals what over... Anyway, so K equals 40. Then step 2, calculate the value of P when V is 2. So P we don't know. 40 is K and V is 2. So here we go. So P equals 20. And that's... Oh, I only get 1 mark for that. I expect you'll get more in a proper exam. Expand and simplify. A bit of surds work here. I've used the smiley face method. So 2 3s is 6. Root 2 root 8 is root 16. Root 2 times 3 is 3 root 2. And the bottom, I don't know why I haven't put that little curve in there, is 2 times root 8 is 2 root 8. Simplify it. Root 16 goes down to 4. And 2 root 8 goes down to 2 root 4 root 2. 6 add 4 is 10, that stays the same. Root 4 is 2, so 2 times 2 is 4, so it's 4 root 2. Then you've got 10, add, now here you've got 3 root 2s, here you've got 4 root 2s, so that's 7 root 2. So 10 add 7 root 2. Question 4, solve the equation. Here you go. What I've done, I've cross-multiplied. If you like, you can use that grid method we do to get the bottom number the same. But that's when you've got to... I'll just quickly show you here how to do that in case you're not sure. You go like this. And this is what we mainly use with the younger students, but feel free to use it if you want. You can do x over 2 and 2 over x, add 1. Blank that one out. Put times there. So 2 2s are 4. X times x add 1 is x squared, add x. And 2 times x add 1 is 2x add 2. Now that's your bottom number there, and you need to do that, take away that for your top number. So that's exactly what I've done here. So let's keep moving on. I've multiplied both sides by 2x add 2 to get it over this side. So I should probably say, when I go down, we're timesing by 2x add 2. Because anything times 1 stays the same. That gives you this. Then I've taken 2x off both sides and 2 off both sides to get that back to 0. So we take 2x off here, you get to a minus x, and take 2 off, you get to minus 6. So you're left with that. Factorise it. X add 2x, take away 3. So x is either minus 2 or x is 3. Because either one of these has got to be 0 to make that 0. Because anything times 0 is 0. Question number 5. ABC is a right angled triangle. All the measurements are in centimetres. Show that x squared take 4x take 12 equals 0. Right, first of all, what I've done, I've substituted the algebra into the Pythagoras theory or theorem. There we go. So a squared add b squared is c squared. A squared is x squared. B squared is x add 2 squared, and c squared is x add 4 squared. So I've multiplied those out here using my smiley face method. So you're left with x squared, add that, equals that. What I've done, I want to get this to be 0. So I've taken x squared off both sides, it knocks out one of them. I've taken 8x off both sides to get rid of that, so it takes that down to minus 4x. And I've taken 16 off both sides, so that takes that down to minus 12. So that obviously equals 0, and that's what you're asked to show that it equals 0. Next one, find the value of 27 over 8 to the minus 2/3. First of all, we're going to ignore the minus for a second, because that makes it a bit more complicated. If it's the power 2 over 3, the bottom one, so that means cube root it. So the cube root of 8 is 2, and the top one means to square it. So cube root of 8 is 2, squared is 4. Cube root of 27 is 3, 3 squared is 9. So that would be 9 over 4. But because it's to the minus, it means it's 1 over 9 over 4, because that's what the minus means. So I've changed that to 1 over 2 1/4, because that's what that is. I want to get this a whole number. The only way I can do that is multiplying it by 4. So I've got to multiply the top by 4. So if I multiply both of them by 4, I get 4 over 9, and that is your answer. Next one, question 7. Make k the subject of the formula. I've done it step by step by step. Multiply by k, take away 2 to give you that, then multiply out the brackets. Next one, take tk from both sides. Take tk, so there you go, that goes over there, so take tk. Factorise this side, so take the k outside the brackets, so k1 take away t, it gives you that, but it's just in brackets. And divide both sides by 1 take away t, which gets k on its own. There. So I'll leave that there, zoom out a little bit so you can see my workings from start to finish. Question 8. Change 125 centimetres cubed into millimetres cubed. First of all, you've got to know that 1 centimetre cubed, imagine it, in terms of millimetres, a centimetre, there's 10 millimetres in 1 centimetre. So 1 centimetre cubed is 1 by 1 by 1, but for millimetres it's 10 by 10 by 10. And 10 times 10 times 10 is 1,000. So 1 centimetre cubed is 1,000 millimetres cubed. So 125 centimetres cubed will be 125,000 centimetres cubed. So that's for 2 marks is your answer. Question number 9. Probability tree. Here we go. Jan has 2 boxes. There are 6 black and 4 white counters in box A, 7 black and 3 white counters in box B. Jan takes at random a counter from box A and puts it into box B. She then takes at random a counter from box B and puts it into box A. Find the probability that after Jan has put the counter from box B into box A, there'll still be 6 black counters and 4 white counters in box A. Right, this is a proper A star grade 1. What you've got to think, if she takes one out of box A, then puts it in a box B, then takes it back, she's got to take the same one each time for there to be the same number that she started with. So I've done box A, it's either 6 out of 10 or 4 out of 10 for box A. Then box B, you've got to remember, it says here there's 7 and 3 in there, so you'd think that would be 10, but she just put 1 in there, so it's actually 11. So if she takes a black one out of box A, then in box B, where there's 11 now, there's 8 black ones, because she's put an extra one in there, and that stays at 3. Again, if she takes a white one out of box A and puts it into box B, that means there's not 3 white counters in box B, but there's 4. And the black ones stay the same. So she needs to take a black one out and put a black one back, or take a white one out and put a white one back. So I've worked out both of those probabilities, there and there. So you add them together, which I've done down the bottom, and it gives you 64 out of 110, which you could simplify to 32 over 55. It doesn't say simplify, so either one of those two would be fine. Question number 10. F, G and H are 3 points. FH equals FG, which you can tell because it's got those little dashes on. It means it's an isosceles triangle. We'll need that later. H is due east of F. Now I think that's important because if it's due east, that means that must be a right angle in there. The bearing of G from F is 140, so that means that whole angle here I've drawn is 140. And if that's 90, then that must be 50. I don't know what they're going to ask me yet, but I'm just filling this stuff in as I go along because I think it might be useful. Work out the bearing of G from H. So G from H is down here. So I want this bearing here. What I'm going to do is more than 180. So you won't get multi-choice in your exams, but you can cross out those two anyway. What I've done, I know that's 90 in there. And if that's 50 and it's an isosceles triangle, those two angles must be the same. So 180 take 50 is 130. Half 130, you get 65. So there's 65 each. So you know that's 90, you know that's 65. So add them to, well, there we go. 360, take 90, take 65, gives you 205. and that is your answer for H. Right, bit of algebra here. What you've got to do is multiply 3x add 2 out. So that's what I've done here. Look, 3x add 2 times 3x add 2 gives you that. Take away this lot here, and I multiplied that out as well, which leaves you with this. So 9x squared take away 3x squared is 6x squared. 12x take away negative 7x, so it's a double negative there, so it turns into a positive, so 12x add 7x is 19x. And 4 take away negative 6, again turns into a plus, is 10. Once you've got this, factorise it and it will turn into one of these, and it is this one here. Because you multiply that out, you will get that. Question number 12. Okay, question 12. It's a vectors question. Find the vector OP in terms of A and B. First of all, what you've got to do here, you've got to go from O to P. So we're going to go along OB, and we're going to go back up there. So O to B is just B. It's fairly obvious. B to A, so how do you get from point B to point A? You go back along B and up A. So minus B add A, or A take B. It's probably a nice way of writing it. So B to P is a third of that, because it's a third of the way along there, because you're told about the ratios here, 2/3 and 1/3. So B to P is a third A take B, third of that, multiplied out, third A take a third B. So O to P is along here and a third of the way up there. So OP is B, because that's OB, add a third A, take a third B, and then we just put the algebra together. B take away a third B is 2/3 B, add a third A, factorise it. What goes into 2/3 and 1/3? Well, a third, so it's a third, 2B, add A, and that is the answer in its simplest form. You get 2 marks if you gave the answer like that. Question number 13. It's a circle theorem 1. Again, I'm going to fill in information as I go along, so I can help myself to work it out. I'll zoom in on the circle so you can see what I've done, and I'm going to read about it. P, Q and T are points on the circumference of a circle. The line ATB is a tangent, so that's ATB there. PQ equals TQ, so PQ equals TQ. We're told that because the little dash is there anyway. It means it makes an isosceles triangle. Angle ATP is 58. ATP is 58, so we've got that in there. Calculate the size of angle OTQ. OTQ. So this blue one here, I'll shade in, we're trying to find. Give reasons for each stage you're working. Okay, if TQP is half of 160, because we're going to work out now, if we're told that that is 32, which we can work out, because that's 58, so that must be 32, because it's 90 degrees, a right angle in there. So that's why that's 32. So that means that that must be 32 as well, because these lines here are just the radius, so it makes it an isosceles triangle. So that's why that's 32 and that's 32. If they're 32, that 180, take 32, take 32, must make that 116. And then from that we can work out that this angle is 58, because angle TQP is half of 116, because an angle subtended at the centre of a circle is twice the angle subtended at the circumference of a circle. So that's why we know that is 58. As PQT is an isosceles triangle, PQT is an isosceles triangle, P and T are the same. So these angles here must be the same. So what we can do is 180, take 58 divided by 2. So 180, take 58 divided by 2. Why are we dividing it by 2? Yes, so these angles here are the same. We know that bit's 32. So what I'm going to do is 180, take 58 and divide it by 2 to get 61. That means that this angle here and this angle here are both 61. So to work out this blue one here, we do 61, take away 32, and it gives you 29. I'll show you my workings here, because it's quite a tricky one, which is why it's 5 marks. But just write down stuff you know. You might be able to drag some marks out of it. I'll leave that there. Question 14. A bit of proof here. These can be quite nasty, but they're not too bad. Prove that triangle APC, so APC, the angles in APC are the same as angles CPB. Okay, there's a few, basically this isn't really a writing down math one, it's like a stating the obvious one. Angle APC, so APC, so that's that angle in there, and BPC, that angle in there, are both right angles. So those angles are both exactly the same. So that means there must be 90 degrees left in the triangle. So that means that one and that one must add up to 90, and that must add up to 90. The blue angles are the same because they're alternate angles. So that and that must be the same. As they are the same, it must mean that these pink ones here are the same, because this here will add up to 90, and that will add up to 90. So the blue ones are the same, that and that must be exactly the same. So if you've got the right angle the same, the pink angles are the same, that means the third angle in there also must be equal, because it adds up to 180. Question 15. Callum says 4 meters squared is equivalent to 400 centimeters squared. Is he correct? Give some reasons. No, he's not. 1 meter squared is 100 centimeters times 100 centimeters, which is 10,000 centimeters squared. So 4 meters squared is 40,000 centimeters squared, and he said it was 400. So that's why he's wrong. Question number 16. The diagram shows a circle, blah blah blah. Value of sine 30 is a half. That's worth noting. We're going to need that. Work out the area of the shaded segment. So that's the bit shaded in. So we're going to work out the area of the whole circle, first of all. So the area of a circle is pi times the radius squared. So that's pi times 6 squared. So 6 squared, that's 36 pi. Area of the sector is the area of the whole circle divided by 12, because how many 30 degrees going to 360? It's 12. So we divided it by 12. So 36 pi over 12 equals 3 pi. So that's the area of the sector. Area of the triangle is half AB sine C. That's on the front of your exam paper. So it's a half times 6 times 6. Sine C is a half. So it's 6 times 6 is 36. So we want a quarter of 36, which is 9. So the area of the shaded bit is the area of the sector. Take away the area of the triangle. So it is 3 pi, take away 9. And that is your answer there. I'll show you the whole page on that one in case you want to have a look. Here you go. Question number 17. ABC is an equilateral triangle, so ABC is equilateral. D lies on BC, and AD is perpendicular to BC. Prove that triangle ADC is congruent to triangle ADB. Congruent means the same size. That's something you've got to know to start with. Right, just start naming the obvious. They both share the line AD, because AD is the same for both triangles. AB equals AC, because we're told it's an equilateral triangle. So they're the same. So we just got to work out that, prove that BD equals DC. Well, BD does equal DC, because it's an equilateral triangle, and AD, we're told, is perpendicular to BC. So the perpendicular midpoint of BC, because it's a corner of an equilateral triangle. So that means that must split it down the middle there, because that's a right angle, we're told there. So that means it goes right between point B and point C. So that means those two are the same. So all the sides are the same. I'll leave that there. B, hence prove that BD is a half AB. Well, AB equals BC equals CA, because it's an equilateral triangle, so all the sides are the same. BD is a half of AC, because AD is perpendicular to BC. And because it's perpendicular with a right angle, that means that equals that, and because they all equal each other, that means that to that must be half of that. And that's how I've written it, and that's all you need to write, just by stating the obvious. Question number 18. Vectors again. What we've been asked to do, express Tm in terms of AB. So you've got to go from T to M there. Right, what I do first of all is work out O to P. O to P is A add B. So it's A add B. Then work out OM, but we're told it's the midpoint, so that means it's half the distance, so it's a half A add a half B. So TM, to go from here to here, you've got to go back along here, which is minus A, which is what I've written here, look, minus A. Then you've got to go from O to M, and O to M is a half A add a half B. So add a half A add a half B. So negative A add a half A is a negative half A, add a half B, factorise it, half is common, and I've changed it around to B take A, because don't forget the A is negative. So half B take A, or half minus A add B, if you want. Factorise completely this one here, means put it into brackets. If it's multi-choice, you could just multiply these out, and you will find it's that one. Again, it's unlikely that will come up, but there we go. Question 20, solve this one here. I'll leave that there. Hopefully you can see it all fairly clearly. This second bit is squared, that means times by itself, so that's what I've done here. So it's 4x squared, take 4x, add 1. So I've put that in there. So I've written the whole thing out in full. I've taken 1 off both sides to get rid of that. I've added 9x to both sides to get rid of that, so we're left here. Then I take 2x squared off both sides. There we go. Then I take 3 off both sides. So that's how I get to that. So 0 equals that. Factorise that one. It gives you that. And because it equals 0, x has got to be minus 3 or a half, a positive a half. Because that means one of these has got to be 0 for that to be 0. Question 21. Prove using algebra the sum of 2 consecutive whole numbers is always an odd number. Right, I'm going to say, because it's 2 consecutive numbers, I'm going to call my first number n, and the next number is n add 1. Because it's just the next one on, isn't it? So the sum of 2 consecutive numbers is n add 1. So simplify that is 2n add 1. I'm going to prove using algebra that the sum of 2 consecutive whole numbers is always an odd number. So 2n, so that's the formula for it. So I say n, if n is even, n must be even, because 2 times anything is always an even number. But then when you add 1 to it, it'll automatically make it an odd number. So 2n is even, but when you add the 1, it becomes odd. And that works with any number. Next one, bit of surds work. Quite a nasty one, this. Hopefully it's not too blurry, you can see what I've done. I've split it up. What I've done here, I've done 8 over root 2, take away 18 over root 2 here. Root 18 divided by root 2 is root 9, which is 3. So that's what I've done there, that's my step there. So I'm left with that. I've this one over here, I've multiplied the top and bottom by root 2, because I want to get the bottom number to be a whole number, which I've done there. Then I've done 8 root 2 divided by 2, so it's 4 root 2 take away 3. And this is pretty much in the format that it wanted it to start with. Only you want to flip it the other way around. So you've got negative 3, add 4 root 2. So A would be your negative 3, and B would be your 4. So there's your answer there. I'll leave that up there so you'll see what workings I've done. If you don't know why you should multiply the top and bottom by root 2, it's just playing around with it, and do it on scrap paper, and it will take a few goes, but if you play with it you will eventually get there. Question 23. The diagram shows a solid cone and a solid hemisphere. There we go. They've both got a base radius of x, that means that's the same. The cone and a height of h, and the hemisphere is a base radius of x. Because it's a hemisphere, also means the height would be x as well, because that's just the radius from the centre to the outside. The surface area of the cone is equal to the surface area of the hemisphere. Find an expression for h in terms of x. So h is this one here. So this is a very difficult question to start off with, but I start off really common sense. What is the surface area of a cone? Well, it says at the front of your examination paper, but it's pi RL, where L is the slopey height, and don't forget the surface area of the bottom, which is pi r squared. That's the surface area of a cone, just get that written down. Surface area of a hemisphere, it is 4 pi r squared, but don't forget it's only half of 1, so divide it by 2, and then you need to add on the circle at the bottom, which is pi r squared. That can be simplified to 2 pi r squared add pi r squared. That's 4 divided by 2 gives you where have we gone? 4 divided by 2 gives you that. So then you're left with this one over here, pi RL add pi r squared there. equals that, because we're told that they're the same. Now let's start playing with the algebra a little bit. By the way, what I've done now, I don't think it's overly complicated. I've just got the formulas from the start of the examination paper. Let's work through it. I've taken pi r squared off both sides because they're the same, which simplifies it to this. I've replaced r with x, because look, x up here we're told is the radius and it's the same, so we can replace r with x. That's what I've done in this step here. Divide both sides by pi, so that gets rid of pi. Divide both sides by x, it gets rid of x, so you're left with L equals 2x, and that's something we need to remember. What we're going to do now, we're going to use Pythagoras here, because we need to find out what h is, and we know that the long side squared, take away the short side squared, will equal h squared. So we're going to use Pythagoras. H squared equals L squared, take away x squared. H squared we don't know. L squared, well, L is 2x, so 2x times 2x will give you 4x squared. Take away x squared, because it's take away, up here it's just take away x and we square it, so it's just, that's why it's x squared. So h squared equals 4x squared, take x squared is 3x squared, square root both sides, so h equals root 3 times x, so h equals x root 3. 4 marks for that nasty question. Question 24. 8 centimetres cubed multiplied by 100 equals 8 metres cubed. Is marked right? No, because 1 metre cubed, imagine a metre cubed, it's actually quite big, is equal to 100 centimetres times 100 centimetres times 100 centimetres, which is 1 million centimetres cubed. Why I put squared there, I don't know, that should be cubed. So 1 metre squared is a million centimetres cubed, 1 metre cubed. So 8 metres cubed will be 8 million centimetres cubed, and 8 times 100 is 800. So he's very, very wrong. Question 25. Construct the graph of x squared add y squared equals 9. Zoom out a little bit. What you need to do for this one is as follows. You've got to get your compass, and look at the y-axis, if y is 3 and x is 0, well, 0 squared is 0, 3 squared is 9. So that equals 9. And that will also be the same for negative 3 as well, down here, because negative 3 times negative 3 is also 9. If x is 3 and y is 0, that would be 9. And the same thing for minus 3. And what you're actually going to get, and you've just got to remember to do this, is that get your compass, put on the 3, and the graph will actually be a circle. So at any point along here, let's just draw that one properly, x squared add y squared will equal 9, and you'll see they're all going through the points 3 and minus 3, 3 and minus 3. If it was x squared add y squared equals 4, you should go through every point that equals 2. Question 26, bit of vectors work here. You're told it's a regular hexagon with centre O, there you go. You've got your AO and your OB, OA and your OB, fair enough. The line AB is extended, that's this line here, is extended to point K, and we're told that AB to BK will be in the ratio of 1 to 2. So that's 1/3 and that is 2/3. So we're going to write the vector CK in terms of A and B. I think we're going to go up here and go along here. So CB we know is just A, because it's the same. So CB equals A. We're going to work out what A to B is first of all, then we're going to double it to work out B to K. So AB is minus A down there, add B, so that's how you get from A to B, just down there and up there, or it's B take away A. So B to K is 2 lots of that, so it's 2B take 2A. So we now know how to get from C to B and from B to K. C to B is A, add B to K, which is 2B take 2A. Simplify this, A take away 2A is minus A, add 2B, flip it around, you get 2B take away A, and that is your answer. Question 27, a little bit more vectors work here. We're given the vectors, that's 2A and that's 3B. We're told that's in the ratio of 2 to 3, so 2/5 to 3/5. Show that OB is parallel, show that OP is parallel to the vector A add B. Well, basically this means calculate OP. So that's what we're going to do. Right, to go from O to P. I would like to go from, well, we're going to work out what A to B is first of all, and that is minus 2A add 3B. So it's down there, along there. So minus 2A add 3B, or 3B take away 2A. So AP is 2/5 of that. So it's a 2/5 3B, take 2/5 2A, 2/5 times, well, 3 lots of 2/5 is 6/5, 2 lots of 2/5 is 4/5. So that's how you go from there to there. Now we're going to work out OP. So to get from O to P, we're going to go up there, along 2A, and down here. O to A is just 2A, so that's where that comes from. And A to P is what we've worked out here. So it's 2A, add 6/5 B minus 2 minus 4/5 A. I've got my A's next to each other, so 2A take away 4/5 A will actually give you 1 1/5 A, which is 6/5 A, and 6/5 B stays the same. So what's common here? 6/5 obviously, so factorise it. 6/5 brackets A add B, and we're told that show that OP is parallel to vector A add B. Well, it must be parallel because A add B is there. It's just 6/5 bigger. So work out OP, and you basically get the marks for that one. Question 28. Rearrange this formula. Nasty one this, I thought, but it's not impossible. First of all, what I've done is taken 1 over V from both sides. So you're left with 1 over U equals 1 over F, take away 1 over V. Leave that side alone. I've cross multiplied this side. So V times 1 is V, F times 1 is F, and F times V is FV. So we're left with V take F over FV is 1 over U. So to make anything 1 over, you put it to the power of -1. But if you do that, you can also reverse it as well. So U equals V minus S over FV to the power -1, because that means to the power 1 over. So it didn't have the power 1 over here, so we're going to put it on, and it will get rid of that one for us. Question 29. Use the graph to find estimates for the solutions of. First of all, I think we're told that curve is x squared take 5x take 3. So that's that curve here. So use the graph to find estimates of the solution. So equals 0, where does the curve go through? 0, minus 0.6 and 5.6. When it equals 6, I've just drawn a line up here at 6, and you want that point and that point, which is minus 1.4 and 6.4. Use the graph to find estimates for the solution of the simultaneous equations, blah, blah. Right, this one here, y equals x squared take 5x take 3, we've already done. That's the curvy one you can see on the graph. You've got to draw the line y equals x take away 4. And the way I've done this is just plotted some points. So y here is 2 and x is 6. So y equals x take away 4. So 6 take away 4 is 2, brilliant. 4 take away 4 is 0. 2 take away 4, sorry, is minus 2. So that's how I've drawn that line. And again, see where they cross each other. There are your answers. Put down the coordinates where they cross. So x is either 0.2 and minus 4, or 5.8 and 1.9. There we go. Question 30. The diagram shows a right-angled triangle. The length of the base is 2 root 3. The length of the hypotenuse is 6. The area of the triangle is A. Show that A is equal to k root 2 and give the value of k. Right. We're going to use the Pythagoras, first of all, to calculate x, because the area of a triangle is half the base times the height, or base times height divided by 2. So we need to work out what this is. So we're going to use Pythagoras. So x squared equals 6 squared take away that. 6 squared is 36. That squared, 2 squared is 4. Root 3 squared is 3. So 4 3s are 12. 36 is there. Square root both sides. So x is equal to root 24. Split that up, because you can get a nice square number here. So x equals 2 root 6. So that is the length of 2 root 6 is the length of that missing side there. That is 2 root 6. So the area of a triangle, as we just said, is base times height divided by 2. You've got the base, which is that. You've got 2 root 6, which is your height, and divide it by 2. Well, because you're just timesing along here, it's basically 2 root 3, 2 root 6. So those two there, those twos can cancel. So you can get root 3 times 3 root 6. So it's 2 root 3 root 6, which is 2 root 18, which can be written as 2 root 9 root 2. Root 9 is a square number. So that's 2 times 3 times root 2. So 6 root 2 is the area of the triangle. Bit of work there, but just play with your surds and you get a few marks out of it. Right. Question 31. Show that you've got two right-angled triangles here, all measurements are in centimetres. Show that 2a add 2b add 1 equals 2c. If you ever see a right-angled triangle with some algebra here, just put it into Pythagoras to see what happens. So c squared is a squared plus b squared. So we know that is over here. So c add 1 squared equals a add 1 squared add b add 1 squared. You've got to multiply a add 1 squared out. You can do that somewhere else. I've done it. So c squared, so c add 1 squared is c squared add 2c add 1. That equals a squared add 2a add 1, which is that, add b add 1 squared, which is the end bit. Since c squared equals a squared add b squared, we can cancel them. So the c squared, a squared and b squared, they can all go. So we're left with 2c add 1 equals 2a add 1 add 2b add 1. Just take 1 from both sides. So you're left with 2c equals 2a add 2b add 1, and that is what it's asked us to show. That 2c equals 2a add 2b add 1. So if you're not sure, put it into Pythagoras theory, have a play around with it. A, b and c all cannot be whole numbers, integers. That's what whole number means, an integer. Explain why. Okay, well look, what I've done here, 2c equals that, which we've worked out. I've divided both sides by 2. So c equals, so c equals, just obviously divided by 2, it's just c. Divide this whole lot by 2. So I'm going to assume that a and b are integers. Now it doesn't matter, because if they're odd or even, if you times it by 2, it'll always be even. Like 3 times 2 is 6, 4 times 2 is 6, 5 times 2 is 4 times 2 is 8, 5 times 2 is 10. So that and that will always be even. But then if you add 1 to it, it'll always make it odd. And if you half an odd number, you're going to get a fraction. So that's why if a and b are integers, then c must be a fraction. Question 32. Here's a shape a, b, c, d, e. This is the last lot here. Rearrange this formula to make x the subject. We'll go back and worry about it in a minute, but that's what it's asked us to do first. Here are my workings. Let me talk you through them. I hope you can see most of that. First of all, we've taken 3x off both sides, so p take 3. Times both sides by 2 to get rid of that. So it leaves you 2 lots of p. Multiply the brackets out, gives you that. Added 6x to both sides to give us this. And I factorised it this side because x is common, and I'm trying to get x on its own. Scroll down a little bit there. Since I want to get x on its own, I've divided both sides by pi add 6, so it'd be 2p over pi add 6 equals x. So that is what x is equal to. Part B was a bit tricky, and I thought 3 marks is a bit stingy, but we'll have a look at it. Last question on the paper, this. The area a centimetres squared, the area of the shape is given by a equals kx squared when k is a constant. Find the exact value of k. Right, first of all, you're told that that's a square, because it's 3 sides of a square, and that is a semicircle with diameter AD. Right, the area of the square is x squared, because it's x times x. So that will give you the area. Excuse my poor accuracy, but that's the area of the square. As that is a semicircle, x over 2 must be the radius. So the radius of there must be x over 2. That didn't come out very well. I'll show you again. So that is x over 2. So let's see what we can do over here. So the area is equal to x squared, which is what I've got there. Area is equal to x squared, add, now the area of a circle is pi times the radius squared. Bear in mind that's the radius. So you want half, so it's pi times half of x, which is the radius, squared, and then you want half of it because it's only half a circle. So if you simplify that, you get x squared, half times a half is a quarter, pi x squared. That's the area of the whole lot. So you're told here the area is equal to kx squared. So kx squared must equal this. So kx squared equals x squared add a quarter. Okay, and then we sort of whittle our way down this and try and work it out. First of all, subtract x squared from both sides leaves you with that. Let me zoom in a little bit so you can follow it. That I factorised this side because I'm trying to cancel stuff down, so I get x on its own. Then when I do that, I can divide both sides by x. So that gets rid of one of the x's. That x squared divided by x becomes x. I can factorise this side again, put x on the outside, then I can divide by x again. So I've got k take away 1 equals a quarter pi, add 1 to both sides. That means k equals a quarter pi, add 1. And I'll leave those workings there for you to have a look at. And that is the end of the paper. If you've done well on that, well done. That was all A and mostly A star level work. So top stuff.